A random sample of 20 Americans showed that the mean time spent on housework was 29 8/10 hours a week, with a standard deviation of 6 7/10 hours. Find a 95% confidence interval for the mean time spent on housework per week by all Americans. Okay, so to construct the confidence interval, we first need to identify the percentage from the problem that we need to look for, and that is 95%. This means that the level for our confidence interval that we're looking for is equal to 1 minus our confidence interval percentage as a decimal, which is 95 hundredths. And if we do the subtraction, we get 5 hundredths. The next step is to determine the degrees of freedom. And the degrees of freedom is equal to n minus 1. Okay, so let's actually go back into our problem and determine what our n value is. A random sample of 20 Americans. Okay, so this is our n value. So we can substitute 20 in for n and subtract 1, and we get 19. And if we switch over to our t-table and take a look at it, we are looking for 0.05 for two-tail, and we're going down to 19, and we get the t star value of 2 93 thousandths. So let's fill that in. So our t star value is 2 93 thousandths. Now, in order to make our confidence interval, we need to find the remaining key features from our word problem, which would be our mean. We also need our standard deviation. And we already found that n was 20. All right, so let's look for our mean. So the random sample of 20 Americans showed that the mean time spent on housework was 29 8/10 hours. So that's our mean, 29 8/10, with a standard deviation of 6 7/10 hours. So our standard deviation is 6 7/10. And now, using all of the given information that we have and our t star value that we found, we can determine our confidence interval. And the confidence interval is going to be equal to our mean, which is x with a bar over it, plus or minus t star, which is our critical t value, multiplied by the fraction of our standard deviation divided by the square root of n. And now we can substitute our values in. So again, our mean is 29 8/10 plus or minus. Our t star value is 2 93 thousandths. And then we have our standard deviation of 6 7/10 divided by n, which is 20. And if we substitute these values into a calculator and evaluate, we can see that our lower bound for the confidence interval is 26 and about 66 hundredths, and our upper bound is 32 and about 94 hundredths, making the correct answer to this question choice B.